Hi everyone, welcome back to another exciting episode of the atom. Today we're going to be learning a little bit about the history of the atom, and our target is really to just understand what exactly does the atom look like. Yesterday we learned that the atom is really small and makes up everything. Today we're going to learn what does the atom actually look like, this thing that makes up everything. What you guys are going to need to do is, as I'm sure you have already found, there is a video link in the description. So you click that video link, you click the video link to get to this video, but there's obviously a Google Doc that you also need to fill in. So there are little boxes in your Google Doc. You have to wait for my screen to load, but you'll fill in those boxes with information about what we will be learning about. Okay. Here I can show you the Word document. Here it is. So there's like these little boxes, and you'll just type in the ends of the sentences, or in some cases, the beginnings of a sentence based off of what is on the screen. Feel free to pause the video at any point in time. You probably will not be able to type and listen at the same time. So maybe you listen first and then type, or you type and then listen. The choice is yours. Okay. But make sure that you fill in that Google Doc. Here it is. Make sure you fill in that Google Doc, and make sure that you press the blue turn in button that will appear at the top of the screen once you have completed the assignment, so that I can go in and grade it. Okay, let's get into our lesson. What does the atom look like? Real quick, I'd like you guys to just assess yourselves. What do you think the atom looks like? In the first box in our notes guide, go ahead and take a moment here. In the first box in our notes guide right here, go ahead and just give me one or two sentences describing what you think the atom looks like. All right. So we're going to be coming back to that in just a little bit. But before we do, I want to take some time and just talk about, what do scientists think it looks like over the history of the millennia? What did we think it looked like? The Greeks actually were the first people to really kind of understand what they thought an atom would be. And basically they just said, kind of like what we said yesterday, it's just a small unbreakable sphere. And they called it atomos, meaning that which is indivisible, that which is unbreakable. And that's where the word atom actually comes from, is from the Greeks' use of the word atomos. It wasn't for about another 2,000 or so years before a guy named John Dalton came along, and he proposed a new theory of the elements. Okay, so feel free to pause the video, type in your responses, then listen to it. Here we go. Okay, so now that you've typed it in, each element is made up of small, teeny tiny atoms. So there are different types of elements out there. You guys have seen pictures of the periodic table. They're all different types of atoms. There's silver atoms, there's gold atoms, there's copper atoms, and oxygen atoms, and hydrogen atoms. There are all of these different kinds of atoms called elements, and that's what Dalton proposed. He kind of envisioned these atoms to be small little spheres, kind of like marbles, and each one was a little bit different. Okay. So then along came a guy called Thomson. Thomson proposed that they were small little spheres, but there were actually electromagnetic charges in the atom. He devised something called the blueberry muffin model, where he envisioned something called, the atom looks roughly muffin shaped. If you have like a bird's eye view of a muffin, it looks kind of muffin shaped. And there are these little negative electronic blueberries in the muffin. The muffin itself is a very positive muffin. As we all know, muffins are delicious. But Thomson did not like blueberries. They were negative. Some people also called it the plum pudding model. Same thing. Okay. So yeah, feel free to pause the video, finish jotting down the notes from this slide, and then we're going to learn about the next model. Here we go. Okay. The next model is called the Rutherford model. This is what a lot of people tend to go to when they think of the atom. Some kids like to call it the Jimmy Neutron model, because in Jimmy Neutron, whenever he has a brain blast, this is the thing that he's like, I've got a brain blast, and this like model of the atom like shoots out of the screen. Same thing in the Big Bang Theory. This is the model that they use whenever they're going from one scene to the next. Um, it's technically made by a guy named Rutherford. And basically what Rutherford said is most of the atom is empty space. There's a nucleus that is a positive center to the atom, and there's these electrons that are flying around the electron. But for the most part, that are flying around the nucleus. But for the most part, it's just a lot of space in this atom. Just empty space. Cool. Okay, we're going to move on to our next and final model. So make sure that you jot down what you need to. I'm going to change the slides now. Oh, sorry, there are 2 more models. I lied. Bohr model. Okay, so basically what Bohr said was he said, you know what, you guys are all right. There are protons in the nucleus, but there are also neutrons in the nucleus. There are positively charged particles, and there are neutrally charged particles. There's a lot of empty space in between the nucleus and the electrons. But the electrons are actually organized not just randomly, but in energy levels, where there are some electrons in a very specific energy level, and if we add energy to the electrons, we can shift what energy level these electrons are in. Okay, cool. The modern model. This is our last model. The modern model is what we currently think the atom looks like today. Some people also will refer to this as an electron cloud model. Effectively, we have a positive nucleus with protons and neutrons, and we also have electrons in energy levels surrounding the nucleus. However, because energy is constantly being added to the atoms and taken away from the atoms, the location of these electrons is constantly unpredictable and uncertain. This is also called the quantum model. It's kind of a fun word, quantum. Whenever you're watching like a sci-fi movie or like the Avengers or something like that, like an action film with science stuff in it, they always throw in that word quantum. Quantum just means quantized or numbered. There is a number associated with everything in this model. Okay. But an easy way to think about this model is it's just an electron cloud. There are electrons whirling around in very confusing and difficult to understand patterns that are in energy levels of sorts, kind of like in the Bohr model. Yeah. It's really wonky. I'll show you guys more pictures of the modern model on Wednesday. Just because it's kind of fantastic, the weird bizarre shapes that atoms actually look like. Like if you were to take a microscope, or if you were to take your body down to the size of an atom and look at what the atom actually looked like, it'd be really weird and bizarre. They just have some incredible shapes. Cool. So, now that we've just kind of seen a couple of pictures and images of what different scientists over the ages thought their model looked like, I want you guys to compare your original ideas of what you thought the atom looked like to the other types of atoms that scientists have made. Is your model similar to any of those other types of atoms? And then just kind of fill in that last little box in the history of the atoms note guide. What are some differences between your model of the atom and what other people thought the atom looked like? What are some similarities? Give me 2 to 3 sentences. All right. Once you are done, make sure to press that little blue turn in button that you guys will have on your screens just to make sure that you receive credit for watching this video and completing the note guide. I'll talk to you on Wednesday. Bye, folks.